Which t-test should you use? You may have noticed that if you use one t-test versus the other, you'll get different degrees of freedom. You may actually be asking yourself, there's more than one t-test? In fact, there's two different t-tests available to you in JUMP. So this is the ANOVA narrow wide data. That is fake data that is made up for explanation purposes. And what I've done here is select group 3 and gone to the rows menu and excluded them because I want to show you with two groups here. So simply just have two groups. Go to Analyze, Fit Y by X. My group is my X, and I'll use narrow as my Y and press OK. And we get this t-test that we'd seen before, this basic plot, and we have to ask JUMP to give us a t-test. Under the red drop-down menu, you'll see there's actually two options. There's the t-test, and then there's the means ANOVA pooled t-test. So remember, the t-test is just the simplest version of an analysis of variance. It's only for two groups. If you run the t-test here, and then also run the ANOVA pooled t-test, we'll be able to see that you actually get identical results here. You get identical results, with the small exception of this line right here on the regular t-test that says assuming unequal variances. If you'll notice up here on the pooled t-test, it reads assuming equal variances. So here's the thing. If you have equal sample sizes, equal number of n per group, so here we have 5 in group 1 and 5 in group 2, or 10 total observations, we are going to get the same results for the pooled t-test as we get for the regular unequal variance t-test. And the unequal variance t-test is simply that. It allows each group 1 and group 2 to have their own amount of variance, So if I show you the standard deviation table here, these are in fact actually equal. And that's why we're getting the same results for the pooled t-test and the t-test. If you have equal n, you'll see similar results in the pooled t and the regular t. And it doesn't actually matter which one you do. It only matters if you have unequal variance. So we have 10 observations here. And so we have 8 degrees of freedom because we are estimating two means. We've got one mean and one for standard deviation, so we have 8 degrees of freedom. If, in fact, we look at different data, so let's look at the test data, and we do Analyze, Fit Y by X, and now let's say we simply want to compare systolic blood pressure as our Y and gender as our X factor, and press OK. Again, we get our generic figure here, and let's ask for means and standard deviations, and you can see here that I have a different number of observations in males and females. And in fact, females is more than twice the number of males. In that case, you're probably better off using the unequal variance t-test. Our standard deviations here are quite different. Let's ask for our t-test, and then let's ask for our pooled t. And we'll look at them both together. And you can see here that we have 41 degrees of freedom in the pooled t-test, 41 degrees of freedom in the pooled t-test because it makes the variances equal. It just takes the overall variance basically and uses that. So each group, men and women, are assigned the same standard deviation, which would be somewhere in the middle, closer to the male standard deviation than here. And then if we look at the unequal variance t-test, you can see that we have an non-integer degrees of freedom, And that's because we have unequal numbers here. We have 30 and 13, and the degrees of freedom calculation for unequal numbers is a little bit trickier. And that's why you see this unequal degrees of freedom. There is a test for equal variance. You don't need to do that. In most cases, you're going to get very similar results. It would be very rare that you would see a significant pooled t and a non-significant t-test. In the case that you do, just verify about your variability. And actually, in most cases, check with a statistician if you're unsure about which test to do. So again, the pooled t-test assumes equal variance. That means men and women would have the same variability in their standard systolic blood pressure here. And in this one, it assumes unequal variance. It says so right there. And in that case, it allows men and women to have their own standard deviation estimate in the t-test.